Okay, guys, back here again for your second video. Hopefully you're able to find those and see the answers posted. Now we're going to use that skill in order to find trigonometric form of complex numbers. And so you have, this is complex form, a plus bi. What we would like to be able to find is the trigonometric form. That is great use, as you're going to end up seeing next week exactly why we use that. There's some pretty complicated things with it to make it easy for you because you're super smart. But notice this guy right here, the graph of this. You'll remember we drew that line. And if you remember, we were over A units. We're over A units. And then we were up B units. And so what we end up doing is, in order to write it in a new form, instead of A and B, we replace it with R and with theta. And in this situation, this is R. And from the video you watched earlier, you recall that R is just simply the absolute value of Z, which we call the modulus. The way we find that R value is the square root of A squared plus B squared. So no big deal there, right? Yeah, I mean it's plain to see. That's something you've seen before. So what about theta? How do we find theta in this situation? Theta is an angle, okay? All right. And so in this situation here, as we want to find theta, we have to kind of determine something that's special about A and B and theta. If you consider this as a triangle, and that happens to be the opposite, and that happens to be the adjacent, which of the three trigonometric functions, sine, cosine, or tangent, has to do with opposite and adjacent and theta? You're correct, that would be tangent. Namely, that the tangent of theta is equal to